Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and I am excited to do this video with you. This video specifically is going to be about the chapter called Probability, looking specifically at the theory behind probability. When you think about probability, there doesn't seem to be a lot of theory that goes into the chapter on probabilities. But I can guarantee you there's a bit more than you might be thinking of. So I ask you to buckle up. Remember this theory video when we go and practice it next or in the next coming few videos. But I encourage you to think about what you are working with and always remember, it's about the exams. It's all about putting this theory into practice. But you cannot put it into practice if you don't have it. So let's start with a probability theory that forms the basics of grade 8 to 11 probabilities. Now, when we look at the theory that we started with when we did probabilities for the first time, we started with a probability formula. We did the addition rule after that, and then the complement rule. Now, the probability formula you are familiar with, but that is the probability that A happens is the number of ways that an event can take place, divided by the number of possibilities that there can be. We call that the sample space. The addition rule, on the other hand, is the probability that A or B will happen is the probability of A plus the probability of B minus the probability that A and B happens. This addition rule, I want you to kind of put a star next to it when you make your notes, because they love to bring mutual exclusivity as well as independence into the addition rule. More on that on the next slide. But let's first of all also not forget about the complement rule. Now, the complement rule says that if we want to know what the probability is that A doesn't happen, we simply say 1 minus the probability that A will actually happen. Now, that is a lacquer rule. It is a fantastic rule whenever you're working with tree diagrams. Or whenever you want to know, what is the probability that I won't have a Coke? That is the kind of things we can determine by using the complement rule. When we look at those two little terminologies that I spoke about earlier, the first one was independence. Now, independence is when the outcome of one event has no effect on the outcome of another. In other words, whatever happens in the first event would not have an effect on the second event. Now, for us, when we want to prove independence, or if they tell me two events are independent of one another, it means that the probability that A and B happens is equal to the probability that A happens times by the probability that B happens. I want you to remember that little formula. Because even if you say, but sir, these two events must influence one another. If you can prove that the probability of A and B is equal to the probability of A times by the probability of B, then the two events are considered independent, whether you like it or not. Let's look at mutual exclusivity. Now, mutual exclusivity is when two events cannot occur at the same time. In other words, it can't rain and not rain at the same time. You cannot win and lose a race. So the probability that A and B happens is 0. Now, please don't try and be funny and say, yeah, but sir, if this guy cheated, yes, he won, but he lost. No, he won the race. He didn't win the race in a nice way. You didn't like the way he won, but he still won the race. So let's not try and get too technical. When two events are mutually exclusive, probability that A and B happens is 0. In probability, ladies and gents, there are 3 very important little tools, can I say, that we use so that we can test how things work and, do they influence one another? What are the possibilities? What are the probabilities? The 3 things we're going to look at in this video is two-way contingency tables, tree diagrams, and Venn diagrams. Now, first of all, two-way contingency tables. Now, two-way contingency tables are used for different people choosing different things. For instance, male and female, whether they like dogs or cats, like that example. Now, this could be any choice. It could be grade 8s and 9s choosing their favorite cool drink. It could be, choosing an event. It could be any choice that we make. What do we use two-way contingency tables for? Well, testing for independence. We want to know, is the event independent? Or, for instance, male and females, or whether they choose dogs or cats, are that independent or not? But something you have to remember is all the rows and the columns have to add up. So in this example, the males 42 plus 10 is 52. For the females, 9 plus 39 is 48. When I look at the dogs, 42 plus 9 is 51. And for the cats, 10 plus 39 is 49. And then both of those columns, or the column and the row, must add up to 100. That's important because that gives me my sample space. So let's quickly then have a look at the second tool, which is tree diagrams. Now, tree diagrams, oh, how I love tree diagrams. They are fantastic little tools, but they can catch you out very, very, very quickly. So when do we use tree diagrams? Now, tree diagrams are used when 2 events or 3 events follow on one another. Like in this example, I flip a coin once, so the probability of me landing on a head is 0.5, while landing on a tail is also 0.5 because it's an even or fair coin. Then the second coin flip happens. The beautiful thing is now we draw, on top of the heads, you draw your possibilities. So head and tails again. Same with by your tails. Heads and tails. Now, I could repeat this process. What must I remember when I do tree diagrams? First of all, event 1's outcome can definitely affect the event 2. Example of that is, let's say you've got a bag with 10 cards in them. I pull out one card, but I don't put that card back. Now, your next event, someone else coming to draw out of that bag. Now there's only 9 cards for them to choose from. All of a sudden, their probabilities become less, or changes, let's rather say that. The second thing you've got to remember is the complement rule, because that's where they want to try and catch you out. They just tell you, you know what, his probability of winning is 0.6. Well, then his probability of losing is 0.4, if those are the only 2 options. Or the probability of it raining on Monday is 0.05. Well, then the probability of not raining is 0.95. So that complement rule, please keep this in mind, because the complement rule will come and save you. Do not forget about it with tree diagrams. Next up, Venn diagrams. Now, Venn diagrams is a firm favorite in the exams, simply because there's a lot of small little things that happen because it's used for visually showing the choices that people make. In this example, as you see, it's a nice explanation. You have item 1 and item 2 as being your two circles. On the left, there's what is only in cycle 1. In the middle, where it overlaps, there's the common things. And on the right, that's what's only in item 2. Just remember, outside of those two items are the items that are not. That's neither in item 1 nor item 2, nor in both. There is a few things to remember. First of all, I can work with numbers or probabilities. Secondly, my numbers must total up to the sample space, to the number of items in my sample space. Thirdly, if it was with working with probabilities, your probabilities have to add up to 1. Ladies and gents, that's all the grade 8 to 11 theory you need. When we talk about grade 12 probability theory, this for me is where my students get stuck, because the fundamental counting principle that we are going to look at is a very simple principle, but with huge implications. It is not just a 1, 2, 3, quick, let's just get an answer. You have to think about what you are doing. The fundamental counting principle is used for calculating the number of options or the number of possibilities that are available. So in other words, if I've got option 1, 2, and 3, and that can carry on, where option 1 has got A possibilities, option 2 has got B possibilities, and option 3 has got C possibilities, then the total number of possibilities is A times B times C. And again, I can expand that. You know, if option 4 had got D possibilities, I would just throw a D there at the back, and it would be A times B times C times D. What I have to remember with the fundamental counting principle is that it works on identical as well as on unique objects. With unique objects, we are going to have a look at how does it work when I have, for instance, 5 different cities I need to visit, or I've got 7 different people to choose from. With identical objects, it could be the shuffling of words. It could be rearranging numbers, for instance. Those are all identical objects. A very important thing to always ask yourself, is repetition allowed? That is going to change the answer. If repetition is allowed, well, that's going to make life very easy for us most of the time. When repetition is not allowed, the maths become very, very interesting at times. So let's have a look before we can get to any practical, any sums or anything. We are going to have to look at an important concept called the factorial, which is n with that exclamation mark. Now, n with the exclamation mark means n times by n minus 1 times by 3 times 2 times 1. We usually use the n factorial when repetition is not allowed. We also use it when we have non-identical objects or unique objects. Lastly, for this specific video, we are going to look at 2 words you need to look out for. The first one is when you think or see the word and. An example of that is, what's a probability of you choosing a boy that is playing rugby. So he's a boy and plays rugby. The moment you see that word and, we need to think about multiply. The moment we think about or see the word or, we need to think about addition. So for instance, what's a probability of you throwing a 3 or a 4 on a dice? Now, because I use the word or, I can use addition to solve that. Ladies and gents, the theory behind probability is very simple and straightforward. In the next coming videos, I encourage you to always think about this theory when you want to try and solve exam type questions. I encourage you to not give up, to not say, oh, sir, I'm struggling. My advice is go always back to your theory and see how it applies in the specific question. This is Mr. VG, and I encourage you to sign up, subscribe, and look out for our next coming videos about taking this theory, applying it in exam type questions. There's going to be 3 videos coming up, one about grade 8 to 11 exam questions, one about identical objects, and one about unique objects. This is Mr. VG signing out. Have a wonderful evening, and remember, you are awesome. Cheers.